How well can you all at the back hear me? Should I speak louder? Are you okay? Louder? This good? Okay, cool. We'll go with this then. Um, week 3. How's everyone doing this morning? Cool. Good. My name is Johnny, and I am a software engineer at Axiom Zen, and also I am a graduate from the program. I graduated a couple years ago, back when it was only 8 weeks. So you guys are really lucky you get to have 12, right? Yeah. Today you're in week 3, day 3, right? Which is all going to be about authentication and security. So we're going to talk about a lot of things that directly relate to what you're working on, which is TinyApp. And also we'll go a little bit deeper into talk about how some of authentication and security is dealt with in the real world. So if I'm not mistaken, so far you got your TinyApp to the point where you can log in and out, right? As of yesterday? Okay, so that makes things a lot easier for me because you guys have already kind of touched some of the code that deals with authentication. But before we get into code, let's just talk about authentication in general. Because let's say you have your TinyApp running right now and someone wants to create URLs. At some point, you want your app to be able to recognize somebody. Why is that? What's the point of authentication? Nobody wants to raise their hand? Yeah, so we could track them because we got to make sure that certain people can access the right things. And when someone tries to access a particular resource, we have to make sure we know who they are. Because what do we know about HTTP? An HTTP request is stateless, and that means that there is no information returned. There's no information returned in between requests. So if you have a client, say it's Google Chrome, say it's some kind of web app, and you request information. Let's say I want to see this particular person's links that they created. You make a GET request to receive that information. But then your app might say, well, I'm not really sure who you are, so enter your password and email, then I'll let you in. And you do so, you make that request to see the information. But once that request is made and a response is received, then on the subsequent request, the server has no way of knowing who you are. So if you think about, I don't know how many people here like go out a lot on weekends, nightclubs and bars and things like that. When you go in, they ask you to pay. They ask for your cover, they ask for your ID, but then at some point, you might want to step out. Now, if you step out to see your friends, to get some food, and then come back half an hour later, the bouncer might not know who you are at all. And they might not let you in. They might ask you to pay again, which doesn't really make sense. So what happens instead? They give you a stamp. They give you some kind of wristband. They give you some kind of identification to make sure that when you come back, when you make another request, that is a request to go in, they know that you are allowed to be in there because you've paid, because you've proven that you can go in. What does that look like for our apps? Sorry? Cookies, that's right. We have cookies that are stored on the browser once they've authenticated, and then every subsequent request will have that cookie attached to it. Let me see if I could show an example. Let's go to, I don't know, any website that takes some kind of login. If I go to github.com, and actually let me open up different on incognito right now. And I sign in. I hope it's not 2FA. Of course it is. Where's my phone? Of course, it's 2. 99201. We'll talk about why 2FA is really important, actually. Probably one of the best ways to make sure that your app is secure. Once I've logged in, I can check the application tab. How well can everybody see? Should I blow this up a little bit? Is this good? OK. You can do this on any website that requires login. If you go to the application tab, you can see all the things that are being stored by websites on your browser, on your client. And in this case, what we're curious about are the cookies. If I open up the cookies here and go to github.com, I can see all the cookies that GitHub has stored on my laptop, on my browser. And because of these, GitHub doesn't have to ask me to log in every time I want to go to a different page. If I want to go to the marketplace, I don't have to sign in because those cookies are being attached. Now, how can I go even farther? How can I make sure that those cookies are actually being attached? I know that they're here on my browser, but where can I go to check that they're actually being sent with every request? How experienced is everyone here with DevTools? If I wanted to check requests, where would I go? Network tab, yeah. So here in the network tab, I can see the requests that are being made to GitHub. And I can go to cookies and see exactly which cookies are being attached to this request. Now, if I were to go back to my application tab and clear these, once I hit refresh, GitHub has no idea who I am now. And it's asking me to sign in. If I go to the GitHub homepage, it once again has no idea who I am because there are no cookies being attached to each request because I get rid of all of them from my browser. Any questions so far? Oh, OK, straightforward. Now, we use cookies to keep track on the browser side of who someone is. But there's another side to it, too. On the server side, when that person makes the login, when they register, we store their password. And storing password is something that sounds really simple, but there's a lot to it, especially if you want to do it well. So we're going to go over some of the different strategies that people can use when they're building apps in order to make sure that you're storing passwords in the most secure way that you can. Now, what is the most simple way that you can store a password? How are you storing passwords right now in your Tiny app? The string, right? And I mean, there are many reasons why that's not a good idea. And I'm sure some of them you can guess already. We'll talk about what you can do instead. But at a basic level, when someone logs in, you can when somebody signs up, you can store their password along with their username in a string. And then whenever they log in, you just check that password with the username that they used to log in. And if it matches, then you send it back. But what are the glaring kind of vulnerabilities with doing that? What could happen if your passwords are being stored as a string along with your usernames? What could someone do? A malicious person on your team who has access to your server. They could steal every single password that you have access to, which isn't really great. So there are different ways of storing passwords in a slightly more secure way. One of the more kind of basic ways of doing it, and it's one that I think you'll be doing for your Tiny app, I can't remember correctly, is what? Sorry? Encryption. Yeah, so we're going to talk about encrypting, and we're going to talk about hashing. Those are two different things, both of which are really important when it comes to security, but have a difference to them. And when it comes to passwords, we're actually going to prefer hashing. But I think, you know what, just to kind of start off simple, let's talk about encryption first. Encryption is really just taking a piece of information, translating it into something unintelligible, and then having the receiving party be able to interpret that information so that they can read the info. So let's say, what's your name? Yeah. Sorry? Songshi and I wanted to pass secret messages to each other. So what I could do is write a little card that says, okay, the letter A is 4, the letter B is underscore, and whatever, and I have that key that kind of translates letters to other different characters. And if he has it too, then we can use it to take a message like, hey, how are you? Translate it using that encryption key, and then we can kind of I can hold a sign with a message to him, and no one else in the room can understand it because only he knows how to decode it. That's kind of the basics of encryption. It's just kind of using, taking information, encoding it with a key, and then having the receiving party be able to decode it. This is good. You can use it with passwords, but with passwords, the problem is if you have a decryption key, then someone can always kind of figure out what that is and work backwards to decrypt your password. So it can still be vulnerable in that sense, because if someone has access to your server and they have access to the encryption key, then they can just kind of do what they could have if they had the plain text passwords, but just with one extra step. Unless you find a way of storing that key separately. What typically happens with passwords instead is something called hashing. Now, does anyone know the difference between hashing and encrypting data? Who's heard of the term hashing before? Okay. Exactly. You can't reverse it. If you hash a password, then you turn it into a random string of text that cannot be reversed. Thinking about passwords, what would the logic be behind that? I mean, you want to be able to compare passwords too. So why would you want to go one way instead of two ways? If I can hash a password, what happens? What do you think happens when somebody logs in? So here, I'll draw this out. I have somebody signs up with the username Johnny and the password. Password, never do this. And then it gets encrypted. Oh, sorry, it gets hashed with like some kind of hashing algorithm like SHA-1. And then the password gets turned into XYZ underscore 49 exclamation mark, whatever. This happens when I sign up, when I register. What do you think the process is later on when I log in? What is the server going to do? Because it can't go back, it can't decrypt this password anymore because it's one-way hashing. What do you think happens on the server side when I log in? Yeah. The hash of what? So I log in. This is like me hitting the post sign up endpoint. And then I hit the post login endpoint with username and password. What do I do with this? I take this password that was submitted, I hash it, and then I compare the hash to whatever password is stored for that particular username. And if they match, then that means you've logged in correctly, and you're allowed to be to view the data. If not, then it says, you know, a password incorrect or something like that. So throughout this whole process, the server never actually stores the password in itself. It just takes the password that's submitted through sign up, hashes it, and stores the hash. And whenever someone logs in, it takes whatever password is submitted, hashes that, and compares with what is stored inside the database or in the server to make sure that they match. So when this comparison happens, we're not actually checking password with password because it's already hashed at that point. Does that make sense? Are there any questions? Yeah. The server side. So it still travels through, like at that point when you're submitting the, when this request is going over the internet, this is still in plain text. But like, there's no way for someone to know that this is the proper password unless they manage to intercept that request. I mean, which is possible, but there are ways around that, which I'll talk about too. But this is password, isn't the password that you're using to log in, like when you sign up, when you go back on the site the next day, this is in plain text. And then once it hits the server, it gets hashed in order to make that comparison. Yeah. Yes. And that's why hashing isn't invulnerable. Because what can happen is a lot of hackers, what they could do is they can keep track of all the commonly used passwords and their hashes. And they keep these things called rainbow tables, I think. And these rainbow tables basically are a database of all the common passwords, like password 123, and then all their hashes. And then basically, if I have access to your database, I can see all the hashed passwords, and I can find the ones for the most common passwords, like password 123, user 123, whatever, my password. And then based on that, I can figure out that, OK, these users have this password. So yes, 2 users with different, with the same password will have the exact same hash. But there are ways to prevent that. There are a couple. One is called salt, and the other one is called pepper. I know, right? So basically, adding a salt to a password prevents exactly, what was your name? Peter? What Peter kind of hinted at, which is if somebody knows what common passwords are in their hashes, and they can easily hack, not necessarily everybody in your database, but the majority, because let's face it, the majority of us are human and we use really easy passwords. Salting kind of helps prevent that. What it does is once you sign up with your password, the server is going to add a random character. So literally any character, could be exclamation mark or letter or something like that. And then it's going to hash your password, and it's going to store the salt. So if, for example, let me erase this for a second so we can see better. If I sign up with my password, normally this would get hashed. But with a salt, what happens is before it actually makes it in there, what we're also going to do is add in a special character. And this character is generated randomly. So it could be something like that. And that's going to be different for every user. It's going to be randomly generated. And then the combination of my password and that random character get hashed. And then that hash gets stored. And the salt gets stored as well. So inside your database, you have username, so user1. You have the password. You have the salt, which is Z. And then you have the hash of the combined salt and the password. So at this point, there is no record of the password in itself. You have the hash based on the password and the salt. The salt itself is stored in plain text. But at least that makes it a little bit harder to guess, because then you can have dozens of users in your database who have the same password, but they're all going to have different hashes for them. And then what happens is if I log in the next day with my password, then the database is going to take the username and the salt and whatever password you're trying to log in with, and it's going to hash those two to make sure that it matches. Any questions? Yeah. Mm-hmm.
And then those developer want to change match higher level
Mm-hmm.
and in previous.
Yeah, I mean, if you change your hashing algorithm partway through the lifetime of your app, then you have to make sure that you still have access to the old one to make sure you can compare the old passwords. Otherwise, you wouldn't be able to tell. If you use a new hashing algorithm on old passwords, then it's always going to come out wrong.
For all the like.
I wonder about that. I wonder if there'd be a way, because it's hard. You can't really go backwards. So I think in that case, you'd have to like force your users to make a new password. But yeah, because there's no way to go backwards. Like think about this kind of something I've been asked before too. Like I don't get it. If you have a hashing algorithm, can't you just know how to go backwards? And the thing is, not really, because if I have like the really simplified example that I gave you before, in which every character is converted to another character, then yes, that algorithm can be reverse engineered, so it's not really a true hashing algorithm. But let's say I had a hashing algorithm that I'm literally just making up on the spot that takes every letter or numerical, gives it a numerical value, and then adds all those together to give a number. So your hash, so to speak, will end up being something like, I can't count the alphabet, but like 7, 7, and 4, whatever. And this turned out to be 81. So this would be your hash, but there's no way for you to know that this came from this, because this could also come from a different combination of letters that add up to the same thing. So there's no way for you to work backwards. So in that case, if you are going to change your hashing algorithm, then you have to force people to make new passwords, or like still validate the old passwords with the old algorithm. Yeah, that was a good question. Yeah. Mm-hmm. Oh, it's generated randomly, but then it's stored in your user. So your database is going to look something like this. You haven't learned databases yet, have you? I'm just going to draw a table then. Well, really, it just is tables anyways. So you have your users, and then every row is a user. So you'd be user 1. You'd have your username, Johnny. You would have your salt that's stored when you sign up, so that would be like Z. And then you would have your hashed password, which would be, I don't know, like 74 underscore $, exclamation mark, whatever, so that when you log in, at this point, your database does not know what your password is. But when you log in with my password, or whatever you type in, and a username, Johnny, it's going to go, okay, you're trying to log into the Johnny account. Let's go and pull that out and see what the salt is and the hash is. And then we'll make the comparison. So what I'm going to do is I'm going to take, what your server is going to do is it's going to take the salt, add it to whatever password you just submitted to try and log in, and it's going to compare that to the hash password inside the database. And if they match, then that means you're good to go. So the salt is stored in a database, which still makes it a little bit vulnerable, but it makes it less vulnerable because it's like that much harder to guess. No method is absolutely immune to like breaches or hackers being able to figure things out, but adding a salt makes it significantly harder. That being said, there's also peppers, which are kind of one step farther, and the peppers themselves aren't stored. So when you use a pepper, what would happen is when you log in, the server is going to add a random character, usually a letter, so between A and Z. And it's going to add that to the end of your password and then hash those together. Or yeah, hash those together, save it, and this pepper does not get stored. Now, what happens is when you try to log in, your server has to check 26 potential hashes in order to make sure that one of them matches and that you've logged in properly. And in terms of computation, it's not really that intensive. So there are some apps that kind of use that as another method, because at least when you use a pepper, you are not storing that in a database. So what happens when you log in with Johnny, or no, when you log in, yeah, username Johnny and password. What your server is going to do is it's going to check the hash for Johnny A, then Johnny B, Johnny C, Johnny, like all the way to Z, and it's going to check all of those to see if any of them match whatever hash is stored inside the database, and if one does, then that means you logged in. And the chances, I mean, the expectation is that based on the hashing algorithm, there's such little chance that you would end up on a random one that you didn't create based on your password, that even checking 26 times is going to make sure that it's reliable enough that you can, like, you're not going to randomly get logged in even though you're not supposed to. That's kind of another method. There are some other ones that have to do with not storing passwords at all. And to be honest, especially in terms of people nowadays building apps, those tend to be the more recommended ones. What are we doing? Okay, we're still okay for time. Before we talk about those, actually, I kind of want to look at some code. Do we have questions so far? Nope, okay. We're going to tie a little bit of everything we just talked about together in some code. And then after that, we will take a break and we'll come back and we'll talk about some more security stuff like 2FA. We'll talk about end-to-end encryption and things like that. So I have a really, really simple app running right now. Let me close this. And I'll send you the code to this. But basically, what it does is allows me to sign up and log in. And once I do, I have access to a treasure chest. That's about it. So I'm going to create an account. Username, Johnny. Password, Johnny. Oh, actually, I have to sign up. I create an account. And I'm going to use that same one to log in. So this is telling me that I'm logged in. And if I refresh, if I just go to the root endpoint, it takes me straight to the treasure. Why do you think that's happening based on what we've talked about so far? Why is it not asking me to log in anymore? Based on? Yeah. And if you want to make sure, you can always look inside the application tab and look at the cookies. And there's a current user cookie. As a matter of fact, if I clear it, so let me see where I can. Yeah. And refresh, now it's not letting me in anymore. It's good to even understand on a deeper level, though, what's going on with the code, because that's what you're all going to be writing for your Tiny app. what I can do, I've been running node. Am I running node inspect? Oh, I think I have it open already. Where is, here it is. Has anyone here used node inspect? How do you inspect code when you're running a node app? Okay, I'm gonna show you something. I'm gonna close this. I'm gonna kill the app. So instead of doing node server.js, I can add -- inspect right before. Oh, I can't spell inspect clearly. There we go. And now, when I run the app, I'm gonna see a little green icon on the left here. If I click the node icon, it's gonna open up the dev tools, where just like you can inspect a web app, a client-side app, you can also inspect a server-side app running on Node using this. So this is being logged from. Let me look at the code. It says server.js line number 131. If I go back to my code, look at server.js 131. Am I looking at the right one? Oh no. Code no. 131. Can everybody see the code okay? Or is it too small? Better? Okay. But I don't like having to hop back and forth between my IDE and my client to see what's going on. So I can just go here and look at sources. And if I go to server.js, I can put a breakpoint to see what's going on at any particular time. So if I hit the login endpoint, then I'm expecting post login that I'm checking to see if the cookie, if the password matches the one that I'm putting in. And then from then on, I can let them in or not. So let's try that right now, actually. So Johnny, login. And I just hit this breakpoint now. So I kind of paused my app right at this particular time, right when I'm hitting the post login endpoint. And I can see inside the request body, I'm submitting the password Johnny and the username Johnny. So what I do from here is that I first find the user. So find user is the method that I defined. Oh, here it is. Data.users.find. Who has used array.find before? Who does not know how it works? Okay, I'll explain it really quickly. What do you use right now? Right, if you want to find something in an array, what do you use? If I have an array of a bunch of animal names, and I want to find dog or something like that, what would I use? You could loop through it, yeah. Contains is a good one, yeah. Contains is good, actually. Contains would be perfect. Let me actually run this really quickly. So if I had const animals, well, actually no, contains will tell you if it's there or not. So like animals will go like cat, we'll go dog, we'll go fish. Oh, I think it's still paused. No. We'll let this run. Okay. So, assuming like this is a really long list and I have no idea where dog is within that list, but I know it's in there somewhere. How do I pull that out? Everyone here would use a loop? Okay, so loop is one way. If you are looking for primitive values, you can also use animals dot index of. Who's used index of? What does that tell me? Yeah, so I'll do like index of dog. And now it tells me, okay, it's at the first index. But the thing is, index of takes a value and it compares those particular values. The problem is, when we're talking about users, it's a bit more than that because you're dealing with objects. So if I said users equals name, Johnny, and then name, Alex. We'll do const. I forgot to close the array. If I tried users.index of and then passed in this, what do you think I would get? Why is that? It worked before when we did it with cats, but it does not work now when we're using object. Sorry? Because object, anything in an array can have an index. So it's not that, it's the fact that here this string dog and here this dog are pointing to the exact same data in memory. The string dog will always be the string dog. And if you add a letter to it, you're not adding to that string, you're creating a whole new string. So here, this object and this object are take up two different places inside your runtime's memory. So they have the same qualities, like they have the same properties, they both have the name Johnny, but as far as your script is concerned, they are two different objects. If I do something to this object, this one will not be affected. The only way this could work, if I did something like this, if I did users dot push, or actually first I'll do const new user equals name Jim. Oh, can't spell. There we go. And then we'll do users dot push new user. So now users looks like this. Now if I do users index of new user, what do you think I'll get this time? Will I get -1 or will I get something else? Who thinks I'm going to get -1? Put up your hand. You're all catching on. Good. So it works this time. It finds it because what I'm trying to find here points to the exact same object. This variable references the same object that I already pushed into my array. Whereas what I had before, I'm literally creating a new object right now with the same property, name is Johnny. So the reason why I'm explaining this is because the way we can get around that, if I want to find something that has the name of Johnny and I don't have a variable referencing it yet, I can use .find. And find, instead of looking for a value, what it's going to do is it's going to run a callback on every single item in the array. And as soon as it finds one that returns true, it'll return that one. So it's a lot more flexible. So I could do something like users.find and I pass in a callback. So have you all used arrow functions already? Okay, good. So this callback is going to take every single item in the array, and it's going to run something on it. Oh, users.find and user. And if I want to find the one that's named Johnny, then what callback should I get to return? What callback should I put in here that's going to return true once it hits the one that I want? What should this function do? I want this function to return true once it hits the user with the name Johnny. Sorry? I can just do return user dot name equals Johnny. And it returns it. So what it's doing is it's going through every single one of these and executing this callback, passing the item into the argument here. And this callback is expecting a truthy or a falsy value as a return. And as soon as it gets one that's true, then your find method will return the item that it found. That's a lot more flexible because now you don't need references to specific objects before you push them into the array. You can just have a bunch of data that you know nothing about. You have no reference to it whatsoever elsewhere, and then you can just pass in this kind of like testing function that's going to test every single one until it finds something that matches, that returns true, and it's going to return that. Any questions about that? Yeah. Pardon me? Yeah, let's take a look. If we could I can just type in users. That's a really good point. What's your name? Sorry, Reza? As Reza mentioned, if two people have the username Johnny, what's going to happen? What's going to happen is your find method is going to return the first one. Which is fine if you are confident that only one person has the username Johnny, then you can trust it. But you might have cases where that's not really the case. And if you want to return all the users that have the name Johnny, what should you use instead? No, find will always return one thing. Always, always, always. If you want to return multiple things, you should use another method with a very descriptive name, filter. So if I had users.filter with the same callback, now I would get an array with all the items that match, that have the callback return true. In this case, there's only one. So it's just an array of one item. But if there were more users with the name Johnny, then this array would have more items. And then you can also use find index, and that's going to return not the item, but its index. But it works the same way. You pass in a callback, and that callback gets executed with every single one. Are we clear? Okay. So that's what's happening in here. Find user looks through your data and users, and it finds the one that matches the username that is passed in by the post login request when you log in. And it returns that user. And then it does something with it. What it's going to do with it is check the password to make sure that the password is the one that you logged in with. And if it's the case, then you get redirected to treasure. Otherwise, you get redirected to the login page. Let's walk through the hashing example quickly before we go on a break. It's going to be very, very similar to this. The only difference is this time we're going to be adding the hashing step that we described before. Okay, so I'm not logged in here. Let's actually open this up directly so we can start inspecting. And actually, let's see what happens when you sign up. This is probably the more interesting one. We'll go here and sign up. Okay, so I just hit the sign up post endpoint, and now I have the request body that contains the username and the password that I want to use to sign up with. What happens next is we're going to use a package called bcrypt, and bcrypt is going to run a hashing algorithm on the password, and then the hash, which isn't defined yet because the code hasn't hit that point yet, but I'll do the breakpoint here. Okay, this is the hash now, based on the string JK. That hash will now be, along with the username, pushed into the user database. It's not really a database, it's literally just an array in memory. But in a real app, you'd have this stored inside your database. And then you're redirected to the login page. I'm just going to play this out. Now when I log in, let me put a breakpoint on the login side. Okay. Now I'm logging in, and in my request, there's a username. In the request body, sorry, there's a username and there's a password. And the first thing I do is I try to figure out, okay, which user am I trying to compare it to? And I do that by finding the usernames by user. So I'm going to use data user equals data.users.find, and I pass in that callback. User.username equals user. Where is this one coming from? The one that I'm hovering over right now. Where is this coming from? Yeah, the request body. And this one is coming from the database. We want to make sure these ones match. And then if they do, then this user gets returned by the find method. If there's no user, you get redirected to login. If there is a user, then we hash the password that was submitted. And we compare that to the hash password from the database. And if they match, match is going to be true or false. If match is true, you get redirected to treasure. If not, you get redirected to login. So at no point is the password ever being stored directly inside the database. Any questions before we go on break? Oh, okay, so we're going to go for a break for about 10 minutes. And when we come back, we'll talk about some slightly more advanced security stuff. Yeah.
That we have to have it like this, so they're like objects. Are objects.
Oh, that's right.
So I just create a form because how to let's see.
Did they want you to store it like this?
Yes, I mean they give. Okay, so row databases.
I mean, maybe it's even easier then, because then you can just look up, like if I had it like this, then you don't have to do. You can just go like when somebody signs in, you can do something like What's this object called? URL database.
That's like
Then you pass in the URL, something like this, no?
the
Yeah.
URL. That's like the user ID. So because I need to like to convert that user ID
Yeah.
match this one, otherwise I'm not going to show the whole database of an.
Hmm.
Also, when if I do a login,
Yeah.
I have to compare if the password exists.
Okay.
I mean the email and the password.
Yeah.
But yes, I think the only way is with a for loop.
Is that what you're trying to do? So you're trying to
To check email.
check email repetition.
Ah yes, because if that is for another example, when I register,
Yeah.
if the email already
Sorry, walk me through what you're
if
trying
I
to do.
register,
Yeah, yeah.
if the email already exists, I say no. And this is for finding the URLs for the user.
Okay. And what are you confused about?
No. I was thinking that this was easier, but in that case, I will store this like an array, and then it's going to be much easier to find the thing I do.
Yeah. Thank you. Hey.
I used it in spec before, but I didn't use it. So I was trying to play with it.
Uh-huh.
And I read a little bit of the doc. I just not too sure how to connect. I would
Open
go-
DevTools.
It's just I don't really see that icon that you
Oh.
have. So I'm not sure if I have to install
This
something.
is Google Chrome?
Yeah.
What did you I'm confused about why it's not working. And hold on. When you had node inspect. What do the docs say?
It says by default is I think to support with ID,
Mm-hmm.
which I was trying to if I go on my own IP on the port, I could get into
Yeah.
my app, but shit. Yeah, but with the UID that it generated, I couldn't really like if I grab this UID,
Mm-hmm.
I couldn't really do anything. I just don't have a route for it because
And your app is running right now, right?
yeah, like it works perfect. I see that.
Can I see something? Oh man, these keys, I love them. Where'd you get that?
Online.
That's so awesome. How do you open it? When does the right click menu not open?
Sorry?
The right click menu?
That's good.
Oh, over
Yeah.
here. Oh, I see. Mine's two finger.
Yeah, some another person.
Second. What target? I'm not sure if it's even picking it up though. Let's see. Sorry. Where was the?
Course at 8080, so I'm not sure if it.
Let's see.
I
know,
I was
right?
debugging with like console.
Where's your oh terminal's here. 9929 9229. It's supposed to work. That's so confusing because this just says, yeah, 9229.
Shouldn't.
But then, no, if it worked, then your code would have appeared
Oh,
here.
I see.
Are you?
I,
Oh, maybe if you did a different port. Let me see. In the meantime, let me try and look into the docs too. Yeah, mine's been like working for so long that I forgot how I set it up. It was a while ago. You're not using Vagrant, are you? That's Yeah, I don't know how to forward the ports from Vagrant to your main thing. That's why. Okay. I still have. No, 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 don't. Because that port
yeah.
is what your client's listening to. That has nothing to do with what the server debugger is listening to. Yeah, so I don't know how, but when the other mentors come in, I'm gonna see if I can ask it, or I'll just look it up myself. How to like forward a port from Vagrant to your your main desktop. No worries. Hey. Yeah, of course, yeah. No worries. No, 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 no. Yeah. Thanks for letting me know. Yeah.
Can you do all the website designing through the Google Chrome?
Can you do all the website design through Google Chrome? What do you mean?
Like you open a console here, you can see your code, you can change it.
Oh, you can't change anything. All you can do is like set breakpoints and like pause the code somewhere else. So I can say, I mean, I can change something here. Just like if I change something, then that's also. Your Windows doesn't have a command prompt. It doesn't have a. I thought we were all using Vagrant, no?
Oh yeah, but like you have to install Linux on it.
Oh, okay.
Everything on that.
Yeah.
I was like, so there's no way like you can use Windows to do the web designing and stuff.
Yeah, you can use Windows. I mean, it's a little bit more difficult. There are some things that Windows can do that Linux machines can do that Windows can't.
Oh, I see.
But I know, like some people on my work, they only use Windows. Yeah, it's possible.
Oh, okay.
Yeah, it's very much possible. It's just a little bit more difficult.
You like use Windows and then a virtual machine inside it, or just actually use the
They actually use Windows, but it just takes some more configuration. Like a lot of Linux machines, they like make things available for you easily, whereas with Windows machines, you have to go and like do a lot of the setup manually. So it's a little bit more difficult. That's why the guy who does, he's like a very, very smart guy. He knows how to like configure anything and everything. But for people who are just getting started, that's why Linux is more recommended, because they have a lot of things like already made for you. But it's very much possible to use a Windows machine. There are many people in the world that use Windows machines. Yeah. My pleasure. What's that?
I got you.
You got it to work? How'd you do it? You forwarded the port?
It turns out when I brought out Postgres, I forgot to do --inspect.
Oh, I see, I see. There you go.
Thank you.
I think we can keep going. Is everybody back here? Is anyone not here today from this cohort? No, everyone's here? Because I realized that I like for the first half, I've been recording like the welcome screen. So if anybody missed it, they're kind of screwed. Doesn't look like seems like everyone's here today, so. And worst case scenario, there's always a bunch of recordings from previous iterations of this lecture, so it's not the end of the world. Let's talk about some more security stuff. I'm gonna need the board for this. Before we talk about sending data securely, I do want to touch on one more thing having to do with the browser, or actually a couple more things, and that's other ways of storing information having to do with a user visiting your site. So if I'm back on my Treasure website, and or actually let me go to GitHub. Or actually, yeah, here. Is this good? Okay. I'm going to go to the application tab, and we talked about cookies already, so I won't go over that again. However, there's a few other things there that I kind of skipped over. Local storage, session storage, IndexedDB, and web SQL. These are different ways that your browser can use to store information on your browser. Because sometimes a cookie just isn't enough. A cookie is used more often than not for something like authentication, making sure you are who you are. As a matter of fact, if I store a cookie on someone's site, what is the information that I should store within that cookie? What would make sense? Yeah, but what specifically about the user? Because you can define that. What specifically about the user would be a good idea to store as a cookie on their browser? Not quite. That can be stored. That's probably going to be better for local storage, which we'll talk about in just a second. But for a cookie, and in terms of authentication, if you want to make sure someone who is who they are, what is the smallest piece of information that you can store? What is the smallest piece of information that can be used to identify somebody? IP address? No, not IP address. ID. Username, maybe username is good too, but a lot of apps allow people to change their username, so that's not as reliable as an ID. No matter what, an ID inside a database, I know we haven't done databases yet, but as you'll learn, the ID is the one most reliable piece of information about a user. So inside your cookie, you'll want to store something like user ID. If you notice, if you go through cookies though, in GitHub or literally any website, you'll notice that cookies aren't stored as like legible values. They're a bunch of random mess here. Why is that? Or why do you think that it might be? Some of them are legible, like has recent activity, yeah. Logged in is no. But some other ones are just like a bunch of random mess. Oh, if I sign in again, am I signed in? Where's that code? 53660. These are random characters because if they weren't, then they would be easily accessible by potentially malicious scripts. Because unlike on the server, the GitHub doesn't have a whole lot of control over what happens to things that are happening on the browser. Once the cookie is left there on your client, then there's nothing preventing, I mean, there are some security measures, but it's possible for malicious JavaScript code to go in and grab cookies, and then they can do whatever they want, pretend that they were you in order to access your information. There's lots of things that a malicious script could do once they have access to your cookies. And so one of the ways of kind of preventing that is by kind of scrambling, hashing. I think it's encrypted. I'm not sure if it's encrypted or hashed. But basically scrambling that data so that it's harder for malicious scripts to kind of know what to do with them. You also have session storage and local storage. Session storage has to do with what's happening only during your session. And so there you might have things like page visited or something like that. And as soon as you close that tab, it's gone. So no matter whatever is stored here, as soon as you close your tab, it's gone. And then local storage stays there for a while longer. If you can imagine something like a university admissions website, where you're going to have to go through 5 or 6 different pages full of lots of different information, like your personal essay, your references, and things like that. It's unlikely that you're going to have that information. I mean, in a lot of cases, you might not have the time to fill that out all at once. So a well-designed website might give you the opportunity to kind of close things up and then go back and pick up from where you left off. That's something you might store inside local storage. So form data. This person entered these things into these fields so that if for some reason their browser gets disconnected or closed unexpectedly, when they go back to that page, it can pull from local storage and figure out what you already had filled in. this might be more reliable than having to store stuff in a database, because at that point, when you actually haven't submitted anything to university, you have no user information yet. Like, there's no point in having you create an account. I mean, some websites do that. Some have you create an account, and then as you fill stuff in, it gets stored inside the server or in the database. But there are some places who, I guess to kind of save responsibility and kind of offload it to the browser, they say, until you actually submit your application, we don't want to store any of that. So we're just going to keep it inside your local storage. And then when you're ready to submit, then we'll store it inside the database. There's no right or wrong way. You kind of have to think about your use case. If you want to be responsible for like partially filled out information, you can keep it in your database. If not, you can just let the browser worry about it by handling it in local storage. That being said, you'd still have to write the JavaScript code to make sure that that gets stored properly. The browser's not going to figure that out for you. There's also server-side sessions, which are slightly different. Basically, a server-side session is kind of like a session. It's kind of like session storage, except the information is stored on the server, not in a database, but in memory. And it's referenced by a cookie. That I honestly haven't seen that used very commonly, but it's just yet another strategy. In that way, if someone's partially filling out a form for like a university application, then we keep that form data not in the database, but in memory on the server, and reference it with a cookie. And then when it expires after a certain amount of time, then it just gets deleted from memory. And I know I just kind of listed off 3, 4 different ways of storing data, which might be a bit confusing. There's a diagram that I found that kind of compares them really well. Cookies, local storage, and session storage. So the cookies are sent with requests, while local storage and session storage are not. And by the way, session storage is not the same as server sessions. The last one I just talked about isn't on this chart. Session storage is session storage that's stored on your browser, and as soon as you close a tab, then it's gone. That's what this one is. So that is not sent along with any requests. Same with local storage, that's not sent along with any requests. So if you fill out a form and you're not done yet, the browser has no idea. But there is some JavaScript on there that kind of puts that into your local storage so that if you open up that file again, it's going to pull it out. But throughout that whole process, the browser doesn't know anything. And then there's like a little bit of difference in terms of how much you can store as well. I mean, quite a bit of difference if you're talking about local storage, which is why this is what you want to use for storing like a lot of form data, which might have images and whatnot, whereas you can't store a whole lot inside a cookie. So that's why you want to be as minimalistic as possible by storing like just a user ID. And then if you don't care about having the data persist after the person closed the browser, then that's when you would use session storage. Any questions about that? Yeah.
So on my bank website, when I click link, I go to 1 or 2 pages,
Yeah.
and when I click back, it gives me an error. It won't go to the previous website, previous page. I have to like access it by click on the link. I can't go back and forward. Is that because it's storing everything inside local storage? Session storage?
That's a good question. I'm not exactly sure. I think I'd have to like look at the exact use case. I've never built a banking website. I imagine there might be some security reasons why they don't want you to access a particular site a particular way, but that could be it. So if you're going to a particular page, then inside local storage or session storage, there could be a history of what pages you visited, and they can make sure that you cannot go to this page if you've come from that page. You can't go to this page if you come from that page. So it's possible, but I can't tell you for sure. Any other questions? Okay. Let's talk a little bit more about some security stuff. We talked about how if you're sending data back and forth between one person and another person across the world, then you want to make sure that stuff is secure. Earlier, I talked about like having an encryption key and having the other person with the encryption key so that we can send messages to each other and no one can figure that out. But what's the problem in that? I mean, here in this contrived example, it's not a problem because I can literally just walk up to him and be like, hey, here's the encryption key, and then we can start passing notes to each other that no one else in the room can read. But in the real world, why is that a little bit more logistically, I don't know, more difficult? They might change their IP. Think even simpler than that. Like, what's the big challenge in making that happen? Once you have the keys, once both people have the key, then there's no problem. They can change their IP address, but then they can just let each other know, hey, here's my new IP address. But before that, what's the problem? Like, how does those keys get exchanged in the first place? That's kind of the big issue. If both people who are trying to exchange information have keys, then there's potentially no problem in trying to figure out what messages are what. But before that happens, there needs to be an exchange of keys. And that can be, if you're talking about your next door neighbor or the guy sitting beside you, there's no problem. But if you're talking about someone across the world, a foreign government that you want to send information to, then there's no way for you all to exchange keys in a secure way, unless you literally meet in person and like one person passes like a USB or something. But that's not really how things work. So there's a few ways of kind of dealing with that. So you have person, I keep forgetting, I think it's, in a lot of cryptography examples, there's these two generic names. I think it's Sally and Bob or something like that. We'll just go with Sally and Bob. So Sally wants to send information to Bob. Oh, you can't see it? Oh, you're the best, thank you. Okay. No. Can everyone see it? Okay, so Sally and Bob want to exchange information, but they need to exchange a key in order for that to happen, which is a little bit difficult because they live across the world from each other. So what they could do is they can have a central service. So like, let's say this is your email server, or like, I don't know, Google Gmail or whatever. What you could do is negotiate a key with the server, and then Bob will also negotiate a key with the server. And so now Sally wants to send Bob some really important email about some really important stuff. Then Sally's going to encrypt that email with her key, with this key that she negotiated with Gmail. It's going to make it here. Gmail is going to decrypt it. Then encrypt it with a different key, the one that was negotiated with Bob, and then send that over to Bob. And then Bob's going to decrypt it with that same key and be able to read the email. So that's secure because that way you don't have to worry about exchanging keys with Bob. You can just exchange keys with Gmail and let them handle it. What's the weak point in this? It's good, but it's like any security measure, there can be holes. What is the potential point of failure here? Gmail. What is called a man-in-the-middle attack is when someone gets access to Gmail servers and is then able to intercept the decrypted email before it gets re-encrypted again and be able to, I don't know, either read it or use this key to encrypt like a fake email. There's a whole lot of things that you could do once you kind of get in here. So this is relatively secure because, I mean, you would expect that Gmail have strong security measures to prevent that from happening. But like we've all seen in the news a number of times, that's not always the case. Now, there is another way of sending information back and forth in a secure way. And that is something called asymmetric cryptography. Who has heard of that before? Asymmetric cryptography. Who's heard of foreign keys and private keys? Okay. So this took me a while to understand. But it's maybe it's not that hard. Basically, what happens is with asymmetric cryptography, Bob and Sally are each going to generate 2 keys. So A, SA, Sally A, Sally B. And then you have BA, BB. There is no difference between these keys. I mean, they're different, but like they don't have any different properties. Like each could be used for the private key or the public key. It really doesn't matter. Sally is arbitrarily going to choose any one of these and make it her public key. So in this case, let's say she chooses A. So SA is Sally's public key, and he could choose either or. Let's just say for simplicity that he also chooses his A key. So BA is Bob's public key, and this is Sally's private key. This is Bob's private key. The public key is in public. Anyone in the world can see it. Which sounds dangerous, but it isn't. Because these 2 keys have a very special relationship. What is encrypted by one key can only be decrypted by the other key. So an email or a file or something that is encrypted with this B key can only be decrypted by this key, and something that is encrypted by this key can only be decrypted by this key. The same goes here. Something that is encrypted by this can only be decrypted by this, and vice versa. Can anyone have any guesses as to what kind of system of secure data exchange can be made based on that? Anyone have any guesses? I've given you all the information that you need to know so far.
I think I've used something like this before.
Then you should know.
It's like, I remember like when you wanted to send a message, you had to get like a PGP key, and then like something like that. I don't know, but it's like where you was like you type a message, and then you would encrypt it, and then the other person has to verify your key on the other end, and then they can be able to like encrypt your message, and then like want to send it back. It's like some sort of key.
Yeah, you're onto something. Is that your hand up? No? Okay. So, if Sally wants to send Bob a message in a secure way, how should Sally encrypt it? Yeah. So Sally can now send a message, encrypt it with Bob's public key because it's out there in the world. He can just pull it down and be like, okay, I'm going to use this to encrypt it. And then now, as it's going through the internet, no one can decrypt it except for Bob and his public key, and his private key, sorry. In the same way, now if Bob wants to respond and send a message to Sally, he can use Sally's public key to encrypt it. And now this encrypted message can only be decrypted using Sally's private key.
Is this key thing like an encryption method?
Well, it's a system. It's like a general kind of system. Like the actual encryption methods, like depend on what kind of algorithms you use. There's a whole lot of different kinds, but there's just kind of like a general kind of strategy. It's called asymmetric cryptography.
When you say public key, is that like available online?
Yeah, anyone in the world can see it. Anyone in the world can see both of these people's public keys. Everyone get it? No questions? Yeah.
I don't really understand what you mean by encrypting using a key.
You just pull up like the initial it's usually like beginning of TCP key, and then there's like a bunch of random numbers and letters, like 256 or something like that. Then it's just what I'm talking about is that to better understand this, easier when you look at the
keys. Let me see if I have an image for that actually. I do. So the actual algorithms are kind of, I don't know, beyond the scope of this. But if you can imagine a really complicated mathematical algorithm that is this encryption key, or one encryption key, that can only be reversed with the other, that's kind of how it works. And then basically you use each person's public key in order to decrypt one. So if, for example, if we were to oversimplify this, if you have, just to really grossly oversimplify it, you have an email that's a letter, and then I don't know, this turns something into a number. So this can only be reversed with this. So you would take this email. Let me draw it over here. Encrypt it into a number like 1, and then send it over. And then now only this key can convert it back to a number, a letter, sorry. So while it's traveling through the while it's traveling across the internet, it's 1, it's unintelligible. But based on the kind of agreement that these, not agreements, like based on the way that these two algorithms are designed, there's a whole lot of math behind it that even I don't completely understand. Something that is encrypted by this can only be decrypted by this, which means that because this was converted using this encryption algorithm, it can be decrypted using that one back to its original form. In the same way, something if Bob wants to send a message over to Sally, because these two are designed in a way that they can convert messages back and forth between one another and only one another, I can use that property in order to take a message that I have, like hello, and then convert it using this into something. And then now this message is traveling across the internet. And even if it's intercepted, no one can actually decrypt it until it gets here, and then this key can decrypt it. Is this still unclear? Or? Yeah.
So since the key is public, you could grab it in public and then use that to encrypt the message.
You're supposed to.
Okay.
You're supposed to. Because your public key is public. It's there for people to use to send you messages. You can't send me a message until you take my public key and encrypt it. I mean, you could, but then it would just be like plain text. So you're supposed to take someone's public key and use it to encrypt it, because once you've done that, the now encrypted message will not be able to be decrypted by anybody until it's reached the destination and that person uses their private key to decrypt it. Yeah?
I thought the private key and the public key were the same.
No, they're not the same. They're not, like, what I meant to say this is the same is that they're, like, there's no properties that makes one different from the other, like in terms of, like this, one's not written in a different kind of way. They're different, like, one could be used in place of the other, is what I meant. They're not the same, but they're interchangeable Yeah, I shouldn't. If I use the word same, I shouldn't have used that one. They're not the same. They're different, but they're interchangeable and they're intertwined, which means you could use one as your public key, or you could use the other as your public key. It doesn't matter, but you have to pick one. And once you do, you can't switch it. That's all I meant. Yeah, they're different, but they're interchangeable. Like, you could pick either one. Yeah. The keys? No. They're just like if you imagine you had one algorithm, one that turns numbers to letters, and the other one that turns letters to numbers. You can just pick one to say this is my public key, or you could say one to say this is my private key, but it really doesn't matter. Yeah, but they don't have any different properties. Any more questions? Yeah.
Why can't you just reverse engineer it then? I'm like kind of confused in that aspect.
Why can't you reverse engineer?
Yeah.
I mean, in this case, you could technically, but like these encryption are like designed in a way that can't really happen. I'm not going to pretend like I understand the math behind it all, but there are people who dedicate their lives to it, and they've designed these really intricate functions that make it so that you can't. I mean, potentially you could, but it'd be incredibly difficult to be able to reverse engineer it. But potentially, it wouldn't be impossible. Yeah, someone could find a way to work backwards, but I'm sure it'd be really, really difficult. Yeah.
Do you use these kind of things in an application like the server, like maybe to have a key?
Yeah, if you ever register a domain and you use HTTPS, the certificate is going to be signed using this method. If you ever go to a website and you see a little lock on it that says that it's secure, or if the URL is HTTPS, then that means it's using SSL. And SSL requires you to have a certificate signed. And to make sure that the signature comes from you, and there's also a signature from the right certificate authority, they use this way of exchanging information. So yeah, if you ever use a website that has secure HTTPS, then you're going to be using that. Any other questions? These are really good questions. Nope. Okay. I think, how much time do we have left? Not a whole lot. I'm going to wrap it up by talking about what is probably the easiest and also the most, in my opinion, some opinions might differ. Well, from what I've seen a lot, and from what I've read, and from what I've experienced, the most secure way of storing user data. So we're moving a little bit away from this and back to what we talked about before, which is user authentication. Yeah. Oh, you're not going to be using. Yeah, don't worry about this. This is just some extra. I'm just having fun. Yeah, so you're going to be using authentication right now with like hashing with bcrypt. However, when you get into building your final projects, you're probably going to be use some stronger methods. Well, maybe not. It's your demo project. No one's going to like. Yeah, exactly. No one's going to look at your code. Oh no, some employers might. But if you're building an app for production, you'll want secure ways to store user information. And storing passwords, even if you're using hashing, if you're using salting, I mean, if you want to, by all means do so. But there's a better way. What way do you think that is? Someone, oh, actually, no one talked about it yet. The best way is to not store the login data at all. Now, before you look at me weird, I'm not saying like don't authenticate anybody and just like, have anarchy on your app and let anyone access anything. What I mean is that you can have a third party handle the login. And that happens through a protocol called OAuth. Who knows about OAuth? Okay, who's ever logged into an app that asks you to log in with Facebook, or log in with Twitter, or log in with Google, or log in with GitHub? Then you have experience with OAuth. The people who built these apps decided, you know what? I don't want to have to deal with hashing. I don't want to have to deal with salting and bcrypt and all that stuff. I'm just going to let somebody sign in with Google and Google can handle storing or secure information. That is a smart way to do it, and that's the way that I would recommend when you start building apps. Just let the big guys handle the authentication side. But it is important to understand how it works still, because with OAuth, what happens is you have somebody log in through a third party, and once they've done so, they come back to you with a token that says who they are, and then you use that token to store inside your app and basically let them access whatever they need to access. Now, can someone potentially get that token and do things with your user? Yes, that's a risk, but it's much less of a risk because of how secure OAuth is. When you send someone to Google and get them to log in, you can trust that they're gonna be reliable in making sure that they are who they are. Now, because so what was your name what's your name? Zero mentioned diagrams help. So I'm gonna use a diagram for OAuth as well because that one can be a little bit tricky to follow. Let me find OAuth. Okay. The thing about OAuth is it goes a little bit beyond just user authentication. You can use it for just that, and I'll talk about that, but just because, and this might be relevant for your final projects as well, you can do a little bit more because once someone logs into Google, you can do things to your Google account, to their Google account. If someone signs up with Facebook, you can do things to their Facebook account with permission, of course. And this flow designs that, kind of defines how that happens. If you build tinyURL and you have, actually maybe tinyURL is not the best example. Oh, no, sorry, let's use TinyApp as an example. Okay, if I use TinyApp as an example and I have somebody log in with Facebook, so that I don't want to store any passwords, I just want people to sign in with Facebook. What I have on my app, I register my app on Facebook's developer website, and when someone wants to log in with Facebook, I send them over to Facebook to log in. So that happens on the third column over here. Once they do, they come back, they get redirected back to my app with a code. And that authorization code is what I can now use to request an access token. Now, this access token that I can request will be constrained by the permissions that I defined beforehand. So just to rewind a little bit, when they log in, they don't just log in. They'll log into a screen that says, TinyApp wants to access your Facebook account and do this, this, and that. I'm sure anyone who was logged in with an app through Facebook or Twitter or anything has seen a screen that says, this app wants permissions to do this, 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 and that. So these are permissions that you can define based on what your app needs. And then if the user agrees to all of them, they'll come back with the code. And you can use that code to request an access token. And then with that access token, you can do a whole lot of different things. Now, to keep things, one thing that often happens is that the token is used to request nothing but the user's ID. So I just want this person's Facebook ID, and I store that inside my database, and that's it. So now I don't have anyone's password or anything like that. All I have is their Facebook ID. And now whenever somebody wants to log in, they just log in with Facebook, give me the code. Well, the code happens automatically. So once they come back with the code, I request an access token, and I use the access token to get the ID, and I store that. The rest, like the bottom half of this, is what you can do even more with APIs. I have here the Spotify one. Some of you might end up using like Spotify for a final project or something like that. Spotify has a really great API. If you were to build something, like for example, an app that can change someone's playlists, add songs to it, what you would need is once you've gotten that code and use that code to request an access token, that token can now be used to control that person's Spotify account based on the permissions that were defined. So if I have player control permissions in that token, or if I have playlist control, or if I have, I don't know, the ability to follow people or playlists, then I can use that token and the API to make requests to Spotify's API in order to trigger those things. So I could, for example, send a request to add a new song to a playlist. I could send a request to count how many songs have been played in the last 5 minutes or something like that. I'm not really sure. I haven't used it in a while, but there's lots of things that you could do. So OAuth is great both for authentication and for using APIs in order to kind of use user information. If you've ever had an app request to share something to Facebook or to, Facebook doesn't let you do that anymore because I think permissions have gotten more strict, but you used to be able to see how many friends of yours are playing a particular game that you're playing, and that would happen through this process. You sign up with Facebook, and then they would use that token to look through your friends and figure out how many people are playing the same game. So OAuth is great, not just for authentication without having to worry about passwords, because you're kind of like offloading that responsibility to Facebook or Google or Twitter or whoever, but it's also great for, or even necessary for being able to interact with APIs if you're ever going to have an app. A lot of the most, like honestly, a lot of the really interesting final project apps work with APIs like these, like the YouTube API, Spotify API, Facebook API, in order to kind of like control people's account and like kind of do interesting things with it. I've used the YouTube API and it's really great for controlling live streams. Spotify's API is really great for playlists, but you guys are creative. I'm sure you can find some really interesting things to do. I think we're a little bit early, but I don't really have much else. Does anyone have any questions before we kind of wrap up?
What was your final project again?
I'm glad you asked.
I remember you told me last time.
My final project was using this actually. I wish it was still live. God, I haven't maintained it because I think once you get a job, you're like, ah. Once you get a job. But it was, let me see if I can find it. Oh, here it is. This is Oxcord. So this was basically a collaborative jukebox. So if you can imagine, you go to a party, you can see what songs are coming up, and then you can vote songs up and down. And when you did that, it actually moved the songs up and down on the person's Spotify playlist. So we use the Spotify API to do that. It was a fun time. I wish we'd still kept it up, but yeah, after we were done, we're like, this was fun, but bye now. Funny story, actually. This app resulted in me being interviewed as a security expert, which made no sense. I was like, so basically, I didn't know how to use the Spotify API, and I couldn't find resources. I mean, the documentations were well written, but I don't know. I kind of like to read tutorials, so I couldn't find one. So after I made that and like bootcamp was done, I kind of wanted to stand out in a way. So I'm like, okay, I'll write a tutorial. That'll be cool. I wrote this tutorial on how to use the Spotify API, and then turned out to get like a lot more views than I was expecting. And then I got an email from this guy in the UK. He's like, hi, I'm with the BBC, and we're doing some research into like some potential security breaches at Spotify, and so we want to talk to security experts like you. Like, are you kidding? The first thing that went through my mind was like, are you kidding? Like, I was like half a year into my career as a dev. But then I didn't say that. I was like, sure, I'll check my schedule or something like that. I talked to the guy, I interviewed him, and I think it's because like I talked about auth tokens and how they work with the API, and it's like from his perspective that was like a lot more than he knew, so he kind of assumed that I was an expert. But like I literally had learned that just for that tutorial. Like I'd written it like a couple weeks after bootcamp. But yeah, I talked to him for a little while. He asked me some questions, and he ended up writing an article, and like I don't know, it was a really nice little experience. To be honest, that kind of like sort of that article that I wrote then made me interested in teaching, because I was doing it at first for very, very selfish purposes. I was like, oh, this will look good on my resume, so I'm going to make a tutorial and make a video. But then like the response that I got from people online saying, hey, this really helped me out with this, kind of made me feel like, oh, maybe I should keep teaching people. So yeah, I don't know. What is there a moral to this story? There isn't. I'm gonna stop being self-indulgent and just let you all work. Please, does anyone have any questions before we wrap up? Yeah.
Can you show us how to use that inspecting again?
Yeah, of course.
I just like for example, if the user types in a certain specific email and password, like how did you?
Yeah, let me run that again. Do you want to see the one with encryption? The app that I was running, right? Like you're talking about this?
Yeah.
Okay, I'm gonna go to, what do you want to see happen exactly when someone logs in?
Just like, for example, if you type in your username and password, how do you know what they type?
Okay, so when they log in or when they register? Both?
Either.
Okay, let's take a look. So I'm running this and I'm gonna log out. Can I? Oh, I just have to hit the endpoint. Boom. Let's see. Where am I running this? Boom. JK. So when somebody logs in, then the browser sends a request, and that request contains, oh, sorry, that's the response. Within the body, the password and the username. And I pull these out using these two lines. And then I find the user that I want to use to make the comparison of hashes. So I'll go users. This is what users looks like. Sorry, this is what data looks like. It's an array. And just like I talked about before, if I want to find something inside an array and I don't have a direct reference to it yet, and it's not a primitive value, then I have to use find. Because find is going to iterate through all of these until it finds one that matches, that one for which the callback returns true, and then it's going to return that item. So I'm trying to find in this array the item that has the username JK. And that's what happens. And on this line here, it says, if, you know what this means, right? The exclamation mark. So if there's no user, send them back to the login. However, if there isn't, so like, I used to write else, but to be honest, if you have a return inside your if clause, then you don't really need to write else. So this is kind of a cleaner way, because yeah, it won't get here otherwise. At this point, it's going to take the user and compare the password, that is the hashed password. This should be called hash password. It would make it more clear, but it's called password, with the password that was passed in, JK. And bcrypt is going to hash the first argument, compare it to the second, which is already hashed, and then it's going to pass a Boolean that is true or false into the callback that you pass into it in the third argument. That's going to be your callback. It's going to take match, which is going to be true or false. Once we get this far, let me keep playing it. In this case, it's true, and error is undefined, which is good. If matched, that is, if matched is true, then I set the cookie current user to user.username, and I sign the cookie, and I redirect them to treasure. Otherwise, I mean, I also could have put a return here and not put the else. Otherwise, that is, if matched is false, then I redirect them to the login page. So when I play this out, match is true. So, oh, I broke something. I think I paused it for too long. Let me try it again. Or, oh, no, there we go. Hello there, JK. Does that make sense? Cool. I think we're about done. You guys got the rest of the day to work. Have fun. Yeah, yeah.
So what's preventing me from going into the data and just like changing something in the cookies and like authenticating myself?
What's preventing? I mean, technically you could, but a lot of times the cookies that are stored are like encrypted in a certain way.
Okay.
That's the way. That's the reason why we saw a whole lot of gibberish. If you knew what the encryption, if the way they encrypted, if you knew how they were encrypted, then
Right.
potentially yes, you could
Oh, okay.
Yeah.
Because it's stored on
on your browser, so
Yeah.
you could do whatever you want with it.
Oh, I see.
Yeah, but that's why it's like they encrypt it. No worries. Hey.
I have a question about this thing with registering with like Facebook,
Mm-hmm.
Google. So isn't that how they track you, like to have ads designed specifically for you on different websites?
Potentially. I'm not sure, but it sounds like they probably could. I think it's a trade-off. That's probably one of the reasons why some people don't like to use Facebook login for everything, because the Facebook then knows potentially every website that you use, every app. Yeah, it can be dangerous, but I mean, I don't know. It's a price that you pay for convenience.
Right.
Because the other alternative is to like have a password and email for every single app that you use. And I think a lot of us. I am a lazy person, so we want to find the easiest way, even if it means that Facebook knows more about us. Like But yeah, you're right though. It is. They could potentially find out a lot more about you as a result. Yeah.
So I added a breakpoint
Yeah.
where, like in the, oh I see. So do you add a breakpoint here?
Yeah.
If you wanna.
But this is gonna. Yeah, exactly.
Okay.
Let's try it. Forbidden.
Oh, cause it wasn't. It's just something I'm testing.
Oh, okay.
Yeah. Like curious how.
It's not pausing.
Yeah.
That's interesting.
Because I have it here that if you can't find a user, I redirect.
Pause it. Like you put one at 110. And yeah, and then get rid of the one at 109.
And get rid of this one.
Yeah. And play it. Okay, so it is there.
Oh, I see. So you just. Have
Yeah, you gotta put it inside, I guess.
Okay.
Yeah.
Okay. Thank you.
No worries.